Hey everybody, thanks for tuning in to our next free response problem done out by me and so that you can check your work. This one is our second problem from last night. This is our AP Calc 2013 problem about the coffee cup. So let me reread this problem to you as you read along. It says, hot water is dripping through a coffee maker. This is my kind of problem. Filling a large cup with coffee. The amount of coffee in the cup at time t, where t is between 0 and 6, this is the table you were given, which I know is really hard to see here, but you have a copy of this, is given by a differentiable function c, where t is measured in minutes. Selected values of C of t measured in ounces are given in the table above. So the coffee cup is filling up. Let's get a look at this. So when 0 minutes have passed, there are no ounces in the cup. When 1 minute has passed, there are 5.3 ounces in the cup. When 2 minutes have passed, there are 8.8 ounces in the cup. 3, 4, 5, and 6. And by 6 minutes, there are 14.5 ounces of coffee in the cup. So this is just giving us measurements of ounces over time. Now, I took it upon myself to grab a piece of graph paper. I wanted to truly see that C of t was differentiable, smooth sailing, no craziness, no corners, no cusps, no vertical tangents, no discontinuity. So I went ahead and I made a t-axis. You can see here I put the minutes here, and I went from 0 to 6 minutes. And then up the ounces axis, I went from 0 to 14.5. And I just plotted all these XY values from the table. And sure enough, it did make a very nice, smooth, differentiable graph, which you can see here. And differentiability implies continuity. So as soon as they tell me I'm differentiable, I know I'm also continuous. So that's a nice curve. Okay, so now we get into answering the question. So let's take a look at part A. Part A says, use the data in this table to approximate C prime of 3.5. So we are approximating the derivative of C, or the slope of C, at 3.5. So what I'm really doing, if I want to look at it in a picture, if I go to 3.5 here on my x-axis, come up to the curve, 3.5, come, I'm about right here. And I'm looking for the slope of this tangent line. We studied that a while back in honors calculus. Well, it turns out, in order to approximate this slope, since I don't have an equation to take a derivative of, but rather I just have this table, if you just go between the 2 points you actually do know on the curve, like you know this point right here from the table is 311.2, and you know that this other point, which is right, oh my gosh, you know what? I went to the wrong, no, wait a minute, I know this point right here. I'm sorry, I know this point. I was looking at the graph wrong. This point right here is 12.8. So I can find the slope between these 2 points, which by the way are marked right here. Here are those 2 points on the table. So if I want to find the approximate slope at 3.5, I can just use the slope between the 2 points kind of sandwiching this point right here at 3.5. I can get the slope there if I just find the slope. So C prime of 3.5 is going to be the 12.8 minus the 11.2, that's the change in these y's between 3 and 4, divided by 4 minus 3. That's the change in these x's. And so that calculation is going to give me 1.6 divided by 1. Now they want units. They said show the computations and indicate your units of measure. So let's say 1.6 ounces per 1 minute. So what I'm saying is this: when t equals 3.5 minutes, at that exact moment in time, the amount of coffee in the cup is increasing at a rate of 1.6 ounces per minute. I may have even given them more than they wanted there. So again, to find the slope at 3.5, simply find the slope between 3 and 4, and that'll approximate it for you. The slope between 3 and 4, which would be like your secant line here, is a pretty nice representation of the slope of the tangent line at 3.5. Okay, so points awarded. Give yourselves 1 point for the 1.6 and 1 point for the units. They want you to know that the derivative is measured in ounces per minute. Okay, let's go on to part B. Part B says, is there a time between 2 and 4? Okay, so let's look at that. 2 and 4, boy, that puts us, let me see here. I was at 2, 8.8. So that is this point right here. I'm going to boldface that. Okay, so 2, 8.8. And then the other point is 4. 4, I was at 12.8. So 4, 12.8, which I have marked right here. So this one and this one. Boom, boom. Okay. Is there a time between 2 and 4 at which the derivative or the slope is equal to 2? And they want me to justify my answer. Well, the first thing I checked on the slope. Connecting this point, 2, 8.8, and the other point, 4, 12.8. So that slope, let me do that math, that slope is equal to 12.8 minus 8.8 divided by 4 minus 2, and that gave me 4 over 2, which is 2. So that means the secant line, let me draw this secant line here. That means if I connect these 2 points, bear with my turning here, with a secant line, the slope of that secant line is 2. Now, think about what we studied earlier in the year. Isn't there a theorem that guarantees that if a function is both continuous and differentiable on a closed interval, isn't there a guarantee that somewhere in between those 2 endpoints, there is going to be another point where the slope of the tangent line is equal to the slope of the secant line? Do you remember what that theorem was called? I hope that you do, and I hope that you answered accordingly. So here is my final answer for part B. Ready? I'm going to write it right here. C is differentiable, which implies C is continuous on the closed interval 0 to 6. Okay? I'm establishing that. And they told me that in the givens, that C was differentiable. So I'm establishing differentiability, which implies continuity. The mean, here it is, the mean value theorem. The mean value theorem then guarantees a time t, where t is between 2 and 4, at which c prime of t, the slope at that value has got to be equal to the slope of the secant line connecting the endpoints. So that's like mean value theorem 101. But look at how they just brought that randomly into an open-ended free response. So that is part B. And the points awarded would be, if you set this part up right here, did you find the slope connecting the endpoints between 2 and 4? And then did you conclude that the answer was yes by the mean value theorem? So this part B, they were awarding you 2 points for acknowledging the mean value theorem and getting that slope of the secant to be 2. Okie dokie. All right, letter, I should say. Let me pull this aside here. Let's go on to letter C. Letter C. Okay. C says, use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1/6 definite integral from 0 to 6 of c of t dt. And using correct units, explain the meaning of this in the context of the problem. Well, I can tell you right now, as soon as I see this definite integral with the 1/6 in front, I'm thinking average value. Right away, I'm thinking this right here is finding the average value of c from 0 to 6, because the average value formula takes 1 over b minus a, definite integral a to b of c of t dt. So right away, I know that the final answer is going to give me the average number of ounces in the cup. If I'm averaging the c values and c represents the ounces in the cup, this is just going to give me, on the open interval or the closed interval from 0 to 6 minutes, this should give me the average amount of coffee in the cup over the 6-minute time interval. Simple. Now, they want me to calculate this part by finding a midpoint sum. Oh, fun. So let's go back to the graph, midpoint sum. And let's not forget, they want 3 subintervals. So my delta x, which is always b minus a over n, is going to be 6 minus 0 divided into 3 equal subintervals. So each subinterval will be 2 units in length. So my delta x is 2 units. So let's crack back to the graph here. That means if I look at my widths of my rectangles, I'm going to be going from 0 to 2. That's going to be my first rectangle. From 2 to 4. And 4 to 6. And more than that, so each width of my rectangle is going to be 2 times the height, and the height is the midpoint sum. This graph is getting pretty nasty, guys. Let me try to get a different color here. So my height, I have to go to the midpoint, like from 0 to 2, 0 to 2. I got to go to the 1, pull up at the 1, which took me to 5.3, across and down. So my first midpoint rectangle looks as such. It's going to be a 2 by 5.3 rectangle. So where am I here? So my first rectangle, so my midpoint sum is approximately a 2 by 5.3. Now I got to add my next one. My next rectangle is also going to be 2, but it'll be higher because I pull up at the midpoint between 2 and 4. The midpoint is 3, so I pull up 3. Where was I at 3? 311.2, which was right here. Come across, drop down, and there you have it. Second rectangle, second midpoint rectangle is a 2 by 11.2. where is that? I'm losing it here. A 2 by 11.2. And then my final rectangle is going to be from 4 to 6. So it's another 2, but now I got to pull up at the midpoint 5. So I got to go clear up to 13.8 right here. Come across. Fold this back across and down, 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 down. And here it is, shaded in. This is a 2 by 13.8 rectangle. So 2 by 13.8. So I add that, and when I do all of that math, let's see, I get 10.6 plus 22.4 plus 27.6, and that all adds up to 60.6 ounces. Ooh, watch these units. This ought to be good. You ready? This is interesting. It's going to be weird. Get ready. So, you know how this is measured in minutes? And this is measured in ounces? Well, when you multiply minutes times ounces, you get minute ounces. It's weird. Nothing cancels out. So these are ounces times minutes. I know that's weird. 60.6 ounces minutes, or 60.6 minutes ounces, but watch what happens. Here comes the 1/6 in the front. When you take 60.6 ounces minutes times 1/6 minutes, because the 6 up here, that's minutes, the minutes cancel, and you're just left with 10.1 ounces. 10.1 ounces. So, final answer to this is the average amount of coffee in the cup over the 6-minute interval is 10.1 ounces. Okay, so look at all that work, all that work, all that work. What did they give you the points for? Let's see. Let me consult my answer key here. They gave you 1 for the midpoint sum. So you're getting 1 point for the 60.6. If you have that calculation, they're giving you a point. You are getting 1 point for the 10.1. And finally, you are getting 1 point for the interpretation. So if you say that the 10.1 is the average amount of coffee in the cup over the 6 minutes, then you've gotten all 3 points on part C. Lovely. So we've got A, we've got B, we've got C. Let's get on to D and we'll call it a day. So here is part D. The amount of coffee in the cup in ounces is modeled by B of T equals 16 minus 16e raised to the negative 0.4t. Okay, so now this is an equation for the amount of coffee in the cup. No longer are we using this table. We're actually using the equation. This is ounces. This is ounces. Using this, find the rate at which the amount of coffee in the cup is changing when t equals 5. That sounds like a derivative to me. A rate is a slope, which is a derivative. So I'm going to take the derivative of b of t, and I'm going to substitute 5 in, and that's going to be that. So let's take b prime of t. Well, the derivative of 16 is 0, so I'm just going to clear out, get rid of that. 0. Now, minus. Now I see a product rule on my horizon. So the derivative of 16 times e raised to the negative 0.4t is the first times the derivative of the second. The derivative of e to the u is e to the u times the derivative of u, which is negative 0.4. So I've got the first, this is this part right here. I've got the first times the derivative of the second plus the second times the derivative of the first, which just goes to 0. So if I clean this up, really what I have is that b prime of t is, this goes away. When I take this negative times this negative, I get a positive, and 16 times negative 16 times negative 0.4, which is 4/10, actually comes out to be positive 6.4. And then I have the e to the negative 0.4t. That's all I've got, because this goes to 0 right there. And they're going to give you 1 point for getting that. So award yourself 1 point for getting that derivative. Now, b prime at 5 minutes, I have to plug 5 in for t. So that's 6.4 e to the negative 0.4 times 5. And that is going to give me 6.4 e to the negative 2, which, if I don't want negative exponents, I'll rewrite as 6.4 divided by e squared. And since this is a rate of change, we're going to call this ounces per minute. And I don't have a calculator, so I have to leave it like this, and that's fine. In fact, that's the answer they want, and they're giving you a point for getting that answer. So hopefully those points added up to 9. I think they do. Make sure that they do. And that gives you a good analysis of how you did on that free response. So thank you for watching.